All right, let's look at question 6. You're asked to write an equation g of x that is the graph of f of x equals the cube root of x, but we're shifting it 5 units down and 8 to the right. Okay, the minute I see 5 units down, I automatically know that at the end of my new function I'm going to have a minus 5. Up and down is always the y value, and the y value does exactly what it says it's going to do. The minute I see 8 to the right, I know that that's affecting the x value. So the 8 is going to go with the x under the radical. And remember, the x value always does backwards. So instead of a plus 8, it's going to be a minus 8. That's why, if you look at the answer to number 6, y, or rather they call it g of x, equals the cube root of x minus 8 and the minus 5. The minus 5 is at the back, that means 5 down, and the x minus 8 under the radical means the original graph is shifted 8 to the right because x is always backwards. The reason you don't need to put parens around the x minus 8, the radical is acting as a grouping symbol. So the negative 8 is with the x because it's under the radical. Next question, question 7. We're taking the graph of absolute value of x, we're shifting it 5 to the right and 9 up. Okay, let's start with the easy part. 9 up means at the end of the function we're going to have plus 9. Because up or down is the y value and it does just what it says it's going to do. Up is plus. 5 to the right, that means that 5 goes with the x, which would have to go inside the absolute value bars to be with the x. And again, 5 to the right, you think about plus 5, but remember, x does backwards. So you make it x minus 5 inside the absolute value bars. So when we look at their answer, that's how they got the answer, g of x equals absolute value of x minus 5 plus 9. The plus 9 meant up 9, and the x minus 5 inside the bars was one grouping. You didn't need to put parens because the absolute value bars acted like the parens, and the x minus 5 because it does backwards, okay? What I always tell my students is this. Look inside where the x is. What would make this quantity inside here become 0? A positive 5, which is 5 to the right. So it's always a good way to remember that you kind of work it a little bit backwards for x. Question 8. I'm taking the graph 1 over x and I'm shifting it 3 units to the left and 7 units up. Well, you already know the 7 units up means plus 7 because the y value does what it says. 3 units to the left is going to affect the x value. So in this problem, the x value is normally in the denominator, so the 3 is going to go in the denominator with it. And because it says 3 to the left, it's you write it backwards, so instead of x minus 3, which you might think in your brain, it's going to be x plus 3 in the denominator. So my final answer is 1 over x plus 3. Notice the x plus 3 is in the denominator. The reason you don't need to put it in parens is because it's in the denominator, so you know it's with the x. And then, of course, the plus 7 means that entire graph will go up 7. That's the y value, and it does what it promises. Question 9. F of x equals the square root of x is what we're starting with. We're reflecting it across the y-axis, and then it's going to go up 6. Well, up 6 is easy. That just means plus 6. If I'm reflecting something with respect to the y-axis, again, here's what I want you to picture in your mind. Picture an ordered pair in quadrant 1. If you cross the y-axis, if you reflect that ordered pair, if you walk across the y-axis, the reflection of that point is in quadrant 2. That meant that the x value changed from a positive to a negative. So when you're reflecting something across the y-axis, you multiply x by -1. So in this problem, we're doing two things. X is getting multiplied by -1 under the radical, and we're adding 6. And that is why they get the answer, g of x equals the square root of opposite of x, and then of course the plus 6 is not under the radical, it's on the outside. And my final question, at least for the first 10 on supplement D. You're given the function f of x equals the absolute value of x. You're reflecting it across the x-axis, and then you're shifting it 4 to the left. Okay, let's think about the reflection. If I had a point in quadrant 1, and I reflected it across the x-axis, picture yourself going from quadrant 1, and the reflection would take you down to quadrant 4. The y value would change. So that means when you're reflecting across the x-axis, you multiply the original y value by a negative. So that would put a negative out in front of the absolute value. So you see why there's a negative out in front of this absolute value function. Now, we're shifting 4 to the left. Left or right always means x is affected, so you go inside the absolute value bars, and if it's 4 to the left, you do just the opposite of what you're thinking. It would be x plus 4, and that is exactly what we have inside the bars. So the opposite, multiplying the original y value by -1, reflects it across the x-axis, and the x plus 4 shifts it 4 to the left. And an easy way to check that out, look inside the absolute value bars. What would make that 0? -4, and in your brain you can kind of think of that as 4 to the left. We're done with the first 10 questions off of Supplement D.